All right, for this video, we're going to talk about solving equations with addition and subtraction. This is one step solving equations, and so we're just going to kind of review this. I know that you've seen this before, and here we go. Two things that we need to consider here when we are solving our initial equations, and that is the addition property of equality and the subtraction property of equality. And so what it says is this: for any numbers a, b, and c, if a equals b, then what I can do is I can add the same thing to both sides of my equation, because if we think about this as a scale or a balance, then by adding the same thing to both sides, I'm keeping everything in balance. Similarly with subtraction, if I have, again, a equals b, I can subtract the same thing from each side and I remain in balance on my scale. So we use those properties to be able to solve some equations. So it says if the same number is added or subtracted to each side of an equation, then the result is an equivalent equation. So if we start with this example of y plus 7 equals 13, and just for the sake of wanting to, we decide that we want to add 3 to both sides of my equation. Now, I have still now plus 3 and plus 3, and I get down to y plus 10 equals 16. These things are equivalent expressions, because if I solve this, or I think about what this is saying, it says what number plus 7 equals 13. We know that that missing piece is 6, and guess what? I haven't changed anything. This now says what number plus 10 equals 16. That is also 6. I haven't changed the equivalence of these equations by adding the same number to both sides. To solve an equation means to isolate, and that's the key word, isolate the variable having a coefficient of 1 on one side of the equation. So what we're trying to do is we're trying to get the variable by itself. That's what isolate means. So we're getting the variable by itself, and to do that for these problems, we are either adding a number to both sides of the equation or we're subtracting it from both sides of the equation. So a couple of examples here, and then I will let you have a few practice on your own. The first one here, k plus 11 equals negative 21. So in words, what this is saying is what number plus 11 would equal negative 21? And maybe you can do that in your head, but we have these addition and subtraction properties that are going to help us. So if I want to get k by itself, right now 11 is being added to it. I want that 11 to go away. I want it to become a 0 because I know that k plus 0 is k. So that is why I am going to subtract 11, and whatever I do to one side, I need to do to the other side to keep everything in balance. Now, I write them like this so that they're stacked up so that I can go ahead and do the operations that I need to do. And what I see is that positive 11 and that negative 11, they're going to cancel or become 0 because 11 minus 11 is 0. And what I'm left with is k. So k is going to equal, and now I come over here and I just have to simplify these values. Negative 21 minus 11 more is negative 32. I almost said 33. Okay? So negative 32 is the value of k that would make that equation true. For number 2, this time, again, we always want to find our variable and we want to locate it first. Okay? And so in this case, r is on the right side of my equation, and I see that I have 32. This number is with the r on the same side of the equation. So I want to isolate r, and to do that, I'm going to have to make this 32 go to the other side so that it will become a 0. And so since it is positive, I'm going to subtract 32. Notice that this r has a subtraction with it. I'm not worried about that yet. I'll take care of that in a minute. I'm solely worried about isolating r and getting this 32 to not be there. So I need to worry about the sign of the 32, as I'm working through this. So right now, the 32's will cancel. 32 minus 32 is 0. I have my equal sign, and what is left right there is a minus r. 41 minus 32 is, excuse me. And so now I have this equation or this expression left. It says 9 equals negative r. Well, if negative r is 9, then I think negative 9 would be what positive r is. And I have solved. Okay, number 3 is just slightly different. And number 3, what I'm going to do is I'm going to simplify this before I start to try to isolate. Because in number 3 I have t minus a minus, or this is saying t and then subtract the opposite of 16. So when I see a minus minus, I'm going to go ahead and I'm going to make that addition, because doing the opposite of subtraction, this means opposite of a negative number, is positive. So now my equation reads like this: t plus 16 equals 9. I want you to go ahead and hit, excuse me, hit pause, and I would like you to solve this one. And when you're ready to check your answer, go ahead and hit play. All right, so I want to isolate the t by itself. I'm going to subtract 16 from both sides. 16 minus 16 is 0. Those are going to cancel. And t is going to equal negative 7. All right. Now, down here, we're going to throw in some fractions. And we also have this same minus minus rule that we had up above. So again, remember this minus minus is saying I want to subtract the opposite of 5/6. Well, the opposite of 5/6 is positive. So I really have x plus 5/6 equals 2/3. So we're not afraid of fractions. We're going to keep these things as fractions and not make it a decimal. And here's what's going to go on. Okay, I know that x right here is what I want to isolate. 5/6 is being added, so I'm going to subtract. And I'm going to subtract. And so x is going to equal, and now to do my fractions here, subtraction with my fractions, I need to find what's called a common denominator. So I think 3 will go into 6, and I know that if I take 3 times 2, I will get 6, and those will have a common denominator. Well, whatever I do to the bottom, I better do to the top, and so now I have this fraction, 4/6 minus 5/6. Okay? It's also important to keep in mind that this 2/3 was the term that was here, and I'm subtracting 5/6 from it. So order of my terms here absolutely does matter. And when I subtract these, I end up with negative 1, and my denominator here is still a 6. Okay, so I end up with negative 1/6. The other thing that I would like to go ahead and point out here is as you start to do your assignments here, I want to make sure that you are in tune with showing your work. And as you have noticed on each of these problems, I'll go back here to number 3. I went ahead and I fixed any signs that I might have needed to. I rewrote it, and then notice how I wrote down what I was canceling out on both sides of, or on the, in this case, the left side of my equation, and then I knew what I needed to subtract. I'm fully aware that some of these problems you're able to do in your head. I don't want you to do them in your head. I want you to show your work, because when we get to harder problems where you need to have the skill of showing your work, I want to make sure that you have that skill. So please show your work, and kind of as we did with labeling equations, just be prepared that if you aren't showing your work, I'm probably going to hand it back and have you redo it.